The thing that gets me out of bed, my greatest passion, is to try and make a difference with my research, so to bring it to market and actually see it make a difference. I recognise that I'm a scientist. My skill set is driving research in the lab. I thought it was exceptionally important for me to find somebody who had business experience. The spin-out company is quantum-based, and the business-minded person who I partnered with is a chap called Phillip.
So my business partner Robert Young brings great science and great rigour to the party, and from my perspective I have a network of contacts that I've built over the last 20 years that enable me to get to the top of large industry shaping partners and accounts. And part of Quantum Base is about creating that model and showing people how you can actually work with unique science and take that to a global market.
The first product that we're bringing to market actually is quite unique. It utilises imperfections in quantum systems. So the application is in information security, so it's deriving unique identities. So in the same way that your fingerprint is unique from mine, the nanostructure at the centre of our device is composed of hundreds of thousands of atoms, and no two nanostructures in a series of devices are going to be the same. The actual really exciting part of this research is that we're using the atomic imperfections. So we're using what was previously a problem in these technologies for an advantage, so a real application. So the process of forging one of these devices is as complicated as it could possibly ever get. In the real world, one of these devices would be embedded alongside a microprocessor to secure your information as it's transferred either from one part of the device to another, or remotely via a fibre optic or a Wi-Fi connection to secure that communication. There are emerging markets, such as in Africa, where HIV drugs are both expensive but also incredibly important. Counterfeiting is a huge problem in this market. It costs the industry somewhere in the region of $10 billion a year. It's also a real social problem as well. The application here is we coat pharmaceutical products, so a pill, with these two-dimensional materials. They can then be verified at all points of the supply chain, and you can verify that the pill that you're just about to swallow is valid in a database held by a company. Our product is exceptionally cheap, and actually this is one of the real benefits of the technologies. The Royal Society Fellowship is perhaps the most amazing thing that ever happened to me. It gives me research freedom for 5 to 8 years, and I can pick the jobs which are favourable to actually taking my research forward. And it's that freedom which allowed me to actually take some research forks, and actually investigate new questions, and has led to the inventions which underpin the technology that we're developing at Quantum Base. I really want to make a difference.